just because I know a whole bunch of people, oops, not that one, are wanting to view this at a later time. The real question is, do I know where the recording gets saved to? The answer is no, I do not. Why is it converting this recording? I have no idea. That's very odd. So yeah, if you can't figure out how to get both of these screens up, what is this screen about? If you can't figure out how to get both of these screen up, let me know and I will guide you through it. But the instructions are there. So we'll just give it a couple more minutes and then we'll get going. Yeah. Give it one more minute and then we'll get onto it. The first bit is like pretty easy to follow along. So even if people come a bit late, it should be okay. Yeah, okay, we're having a couple more people jump in now, so I might just delay it a couple more minutes. I apologize to everyone that's been waiting, but we will wait half a second. All right, might just get going, whatever. If you're late, apologies to them, but not much we can really do. Cool. So welcome everybody. This session is purely aimed for just getting you familiar with very basic concepts that apply to a whole bunch of different programming languages. So if you've never touched a programming language before, there are many different types of programming languages. We will be doing what's called Python. Arguably, it's probably one of the easiest to get the hang of because everything is quite simple in how it's implemented. Between different programming languages, there are things called syntax, which is the way that the language expects you to write things. This is different for pretty much every language. So when I'm teaching you concepts today, just know that when you go to another different language, that the concept itself will stay the same, but the way that you write it in code will probably be different. So make sure to focus on specifically the concept itself. And what it means as opposed to just how to write it. Because once you go to different languages, which you may or may not have to do, but if you do branch out to other languages, just know that if you understand the concept themselves, it'll be quite easy to implement it in different languages. So make sure that you've got both of these different windows open. This over here is the programming window, the one on the left, and the one on the right is the console. You'll notice that if I type help, it will respond to me. But if I type help over here, it'll be like, it won't do anything. So whenever we write a program, we're going to be writing it in the left. And whenever we run the program, the output will go into the right. It is customary whenever you do a new project or a new programming language to create what's called a hello world script. And all a hello world script does is it will print the text hello world to console. So to make sure that your Python is running correctly, could I please get everyone to type in the programming window, print open brackets, then a double quotation mark, hello world, then close the quotation marks, close the bracket. And then once you've got this, it should like highlight the bracket to tell you that you've successfully closed it. Then what I want everyone to do is to click on run at the top and then press run module. You can also press F5. I'm going to be pressing it. So whenever you see like something pop up here, it's because I've pressed F5. So if you run this, you must save, which I always forget to do before I start. So save it somewhere. I'm just going to save it into the programming course folder. If I could click, that'd be incredible. Cool. All right, and you'll see that over here, it says hello world. That's once you run the file, it says hello world. So could everyone just make sure that you're able to do that? If you get any errors, make sure that you've put the double quotation marks on both sides and close the brackets and that you didn't put a space here, which, never mind, apparently it still works. I don't think it should, but it does. So once everyone's done that, just chuck a yes in chat to make sure that A, you can hear me, B, your Python's working. Yes, cool. I'm assuming since I haven't heard any no's, we are all good. So what have we just done? We've created our very first basic program, and this is pretty much the very first step you can take into actually programming. What we've done is we've used a function, and it's a built-in function called print. In pretty much every programming language, there are built-in functions, and then you can make your own functions. And a function works very similar to how a function on CAS works. If you haven't done methods or you haven't used a CAS before, I do apologize. I'm just going to talk about it quickly. So you know when you define a function on a CAS, you write it as define, let's say f of x equals x plus 1. That's pretty much what happens in programming as well. We can define a function with a name of f, which will take what's called an input parameter. And then using this input parameter, it will output something based on what we write. Print, the function, is already defined for us in Python. And what it does is it takes an input parameter, which in this case is a string called hello world. And I'll go over what strings are soon. And then what it does is it outputs that string directly to console like this. So whenever we use a function in Python or in pretty much every other language, we have to use it the same way that we do on a calculator. If I undelete what I just did, because I didn't want to delete it, when we would use it on a cas, we would type f of, like 5 of something, and that would give us 6. In programming, it's exactly the same thing. We call the function by its name. We open a bracket to say that we want to call the function. We can put whatever we want, as long as it's what the actual function is expecting, and we close the bracket. And then that will then work like this. So that is how we call functions. We open the bracket, we put what we need, we put any input parameters if it's expecting any, and then we close the bracket. In some programming languages, just as a side note, you might have to put a semicolon at the end. You don't do that in Python, so we just leave it as it is, and that's all we have to do. Cool. So this script is, it's basic, it's a good start, but we can make it a tiny bit cooler straight away. So print itself is it prints the console, and it takes an input and it gives you an output. We can do the opposite. We can take an input from the user and use that in our code. So what we're going to do is we're going to create a script that will take an input name, and it will then say hello and then your name. In Python, it's really simple to get user input. All we need to type is input, like this. So if everyone can type it and then run the code, you'll see that nothing pops up. And the reason that nothing's popping up is it's because it's expecting some input from you. So if I was to then say, let's say my name is Ari, you'll notice that nothing happens, but the rest of the script executes. So what's happened here is that input is waiting for you to give it some input. And once it's been given some input, the rest of the script runs. Also, I should just mention, by the way, if you have any questions, if something's not clear, please feel free to ask, just to put it out there. So what I want to point out is that obviously it's a bit hard to know that it's expecting input because it's not asking us anything. If we get rid of these brackets and we just put an open bracket, you'll see that a box comes up. This box in Python is usually really good, and it tells you what it is expecting. Some things, if you don't understand what it says, just ignore it. Like, I don't know what the dash marks preceding arguments as positional only means. Doesn't matter. But what it's saying is that it's expecting a input parameter that's a prompt, and by default, it's nothing. And it tells us what this function does. And it reads a string from standard input. The trailing new line is stripped. Don't need to worry about the trailing new line for now. Once you get into actual programming and text formatting, that's later on. So now what we can type is we can type with a double quotation mark, what is your name? Now, if we run it, it will now say, what is your name? And if we type, let's say, Ari, then again, nothing happens, not yet. But obviously, that doesn't look too good because there is no space between the question mark and the actual input that you type. So what it's recommended to do is to actually put a space at the end of your input, like so, at the end of the input string. And then when you rerun it, and you click it correctly, it'll give a space. So everyone just make sure that you know what input does and that how you enter a string like so. Now, what if we were writing some pretty complicated code, or we didn't actually know specifically, we wanted to make sure that we could come back to this code later and know what it does, which is a good example of something you could be doing now in case you want to understand what we are doing and come back to it later. So to create a comment in code, you can see that these are all comments and they're all in red. To create a comment, you do the hashtag symbol and then your message here. And a comment will not be read by the compiler, which is what actually turns the code into something that will work. The comments are only for you. So you can always put comments at the end of a line to make sure that you can come back to the code, or someone else can come to your code and be like, okay, I see what this person is doing. So for example, we could write a comment here that says, get input from the user, so that we could then know what this line of code is doing. So throughout this entire process, I would highly recommend, especially once we get to a bit more complicated stuff, to put comments so that you can refer back to it, so you can understand what specifically is going on. If you put a comment like within a line like so, it'll just comment the rest of the line out. So you always have to put comments at the very end. Now what we're going to do is we're going to actually take this input and we're going to make it usable. referring back to calculators, you'll remember that you can define variables, like define A equals 100 or B is like 3.14, stuff like that. If you didn't know you could do that on a calculator, you can on the CAS. But what this is doing is it's basically saying that we are setting the value of A to be equal to, in this case, 100. And if we were to then write A and press enter on the calculator, it would return 100. This is what's called a variable. And variables are one of the most basic concepts. And in Python, they're really simple to use. In other languages, they become a bit more annoying. But all the variable does is it says this particular variable name is storing a particular value. Input, the function, returns an output of whatever is typed into the console. So if I was to type Ari, then this would return the string Ari. We can then save this by defining a variable, and we'll call it name. So we'll say name equals input. What is your name? This is going to say that whatever the output of the input command, it's a bit confusing, but whatever the input given by the user is, it will be stored in the variable called name. If I was to then write print name, right, and run it, you'll see that it prints Ari. So what we've done is we've stored the input and we can then use it later on. I could write this 1,000,000 times and it would still work the exact same way. So it's not like you can use it once, you can use it as many times as you want. So now that we can do that, the next thing we're going to talk about is string concatenation. And string concatenation is a fancy way of saying, how can we put one string with another string? Let's say that I wanted to change hello world to say hello Ari. Now, obviously, I could just write hello Ari, but that's not going to be very useful. What if someone else whose name isn't Ari comes? So what we're going to do instead is we're going to write hello plus name. Now, hello plus name is basically saying we're going to put the string hello together with the input that we've got and we've saved in name. Now, unfortunately, it's not quite that simple if you want it to look good. If I run it, you'll notice that it's got no space, which is a bit annoying. Sorry. Joking a bit. Okay. So what can we do to get around this? There are two things we can do. We can add our own space like so. So we're saying that our new string is the words hello plus a string that's just a space plus our name, which would work. Or we could do hello, put a space in ourselves, and then do plus name. Whenever you have a string that's never going to change, like in this case, the string hello will never change. Oops, and remember to close the brackets. Whenever you have a string like that, it's probably easier to do it than to add this plus and then its space itself. But both of these should work and should give us exactly the same thing. If we then wanted to add an exclamation mark at the end, we could add plus exclamation mark, which would work like that. So that's string concatenation. There are a couple other ways you can do it, but for all intents and purposes, we'll stick to this for now. And then when you go and do your own programming, if you want later on, you might be able to figure out a few ways. This is probably the easiest. And so we'll stick to that. Okay, so everyone just make sure that you understand how we can do a bit of string concatenation. It's mostly useful when we want to output stuff, but for now, just make sure you understand the actual syntax of adding two strings together. So what I'm going to do is I'm going to delete this if everyone's ready so that I might just actually delete this stuff as well. Yeah, we'll delete this, and we will go to the next thing. So in every programming language, the programming language will have certain data types that have been pre-configured. And a data type is basically a way that it can understand the particular data that you've given it. So we've already gone over what's called a string. So a string can be anything that's wrapped in quotation marks. That is a string. This is also a string. Strings can be anything, including numbers and symbols. So anything that's wrapped within quotation marks will be a string. And strings are pretty much just any type of text. And they won't really, you can't really do too much with them unless you like modify it if it's got multiple things, if it's got multiple different things like letters, numbers, and symbols. So a string can be anything like that. What I'm going to do is I'm going to define my string to be equal to, this is a string, 1, 2, 3, like this. Now you'll notice that the way I defined the variable or the variable name was with a lowercase m and a capital S. This is just really up to preference on how you want to do it. This is referred to as camel case. This is camel case variable name. You can also do my string, which I think is called snake case from memory. You can, if you want, I wouldn't recommend it, but you can just do it like that. That looks pretty bad. So highly would not recommend. It's just to make it look, just to make your code look a tiny bit neater. My recommendation is to use camel case like that. If you had more than one word or more than two words, sorry, you could do my string is cool like that. And you just keep capitalizing the words. It really doesn't matter. It's just to make your code look a tiny bit nicer. So what if we wanted to instead define a number? So instead of a string, which a string could be the number 1, but that's a string in terms of Python, not actually a number. So when there's numbers in Python, there are a couple of different types. There's what's called integers, which is, for example, 1 to 1,000. Sorry, that's negative. That's 10,000, negative 10,000. These are all integers, and they're integers because they don't have any decimal places. So I'm going to do my int equals 10. And I'm just going to define it like that. Notice that there isn't any quotation marks because we're actually saying that it is the number 10. We then have what's called floats, and floats are numbers with decimal places. And the reason that there's a difference is because of how the code on the back end, when you like do like addition and stuff, will work with ints and floats, and it will work a bit odd at sometimes, which we'll go over in a moment. So floats, for example, could be 3.14, could be negative 3.14, it could be 10.0. Notice that from us, we would naturally ignore the 0.0 because, I mean, it's just 10, right? It's not in programming, so that is actually a float itself. If I got rid of the 0.0, it'd become an integer. It is a float once you put the point. And yeah, any number can be a float. So that floats have decimal places. There's a few others in other programming languages. If you're just doing Python, you probably won't need to refer to the other types of numbers. It's just about how it's stored in memory, and it's way beyond what we're trying to explain today. So we're going to define my float as being equal to, let's say, 3.14. Now what we're going to want to do is point out the differences and why it's important to define the different types. If I wanted to print all of these things together to console, I'd write print my string plus my int plus my float. What do you, someone that's watching, say, what do you expect will happen when I run this code? So if I save this code, what will happen if I run it? Someone just take a guess. The first thing you'll notice about programming is that you will get things wrong pretty much all the time, including me. Even with the basic Python stuff that I'm literally teaching, I will get it wrong. We'll try to add them literally, like 13.14. So those of you that are saying it will error, it will indeed error, and it will say that the error is type error can only concatenate string, not int to string. So firstly, what is an error? Realistically, errors are what you spend the majority of your time on with programming, or just your code doesn't work and you're like, why on earth does it not work? And so this is the process of trying to fix errors is called debugging, and it's what you do a lot of the time. So get ready to spend a lot of time debugging. When you actually look at an error, this thing called traceback will tell you approximately, or as good as it can, where the error is occurring. So it's saying that the error is occurring in this file, which is this one here, on line 5. And it's saying the particular line that the error is being caused in, which is, of course, this line. This here is the actual error that Python is throwing, as it's called. And it's saying type error can only concatenate string, not int to string. Let's say, for example, that we had absolutely no idea, or we were just being lazy, and we were like, okay, I can't really be bothered trying to figure out what this error code means. Can I get help? Possibly one of the most important skills of a programmer is being able to Google things. So what I'm going to do is I'm going to open up a new tab. I use Opera, and I'm literally going to copy paste the error straight into Google. Stack Overflow is an incredible website where pretty much everybody asks questions and then people will try to answer as best as they can. So whenever you have a programming issue, go to Stack Overflow. If you search up an error and it's not in Stack Overflow, good luck fixing it, because it's probably something that hasn't been an issue for someone else. So you'll have a lot more fun trying to fix. But anywho, so this is the error that we want. This is the person that's actually asking the question. And typically you can honestly just skip past it. So although this is a really nicely formatted question, we can just skip to the answers. And the very first answer is usually the best. And it says Python, with broken English, Python working a bit differently to JavaScript, for example. The value you are concatenating needs to be the same type, both int or string. So for example, the code below throws an error. Print and then a string and an integer, which is what we are doing right now. If you recall our code, we are trying to print a string plus an integer. To solve the issue, just add string to your number or value like this. So what the main thing there is to just, whenever you get an issue that you don't understand how to fix, Google it and look at Stack Overflow, and that will help. But what this error is saying is that you can't add a string and an integer together. What we have to do is this thing known as casting, or changing the type. So when you plus things together, typically they have to be of the same type. So you can't plus a string and an integer, or a string and a float. You probably can add an int and a float because they're both numbers. Sometimes in other programming languages you can't. I'm pretty sure in Python you can. So what we have to do is we have to use a couple of built-in functions to convert the types. If I wanted to convert anything into a string, I would type str for string, and then the thing I want to convert. If I wanted to convert something to an integer, I would type int and then 10. And if I wanted to convert something to a float, I'd type float like this. So now what I'm going to do is I'm going to put this in this thing called type, which will tell us the type of thing that is being given as an input. You typically don't really need to use type unless you're debugging. So all type does is just say the specific type of input that you're giving it. And so this invalid syntax error is telling me that typically something has gone wrong on the line above, because you might notice, or someone say, what is the issue with this line that's causing it to give me a syntax error? Missing bracket, correct. So yeah, I'm missing a bracket here. That happens all the time. I'm probably missing brackets here as well. Yep, and I'm missing brackets here as well. As you can see, you just make these mistakes and then you fix them quickly. So ignore the error because I haven't fixed the line, but you'll see that it says that the first line is a string, the second line is an integer, and the third line is a float. What happens if I try to convert something that isn't actually let's say I'm trying to convert something to an integer that isn't an integer. So what I'm trying to say is, let's say I try to convert a string like test, right? Now we can obviously tell that test itself is not a number. And I kind of just gave the answer away by mistake. But when we print it, never mind, I forgot that Python does this. You'll notice that there's another error saying invalid literal for int with base 10 test. A literal typically means an input. So you've given it an invalid input called test. My bad. I thought this would return not a number, but never mind. So whenever you get an error that's something like value or type, you just got to go back to your code and make sure that you haven't accidentally done something wrong with the type of input that things are expecting. So now if we wanted to add this together, we would turn string, we would convert both of these things to strings, like so. However, when we run it, we'll get it that it adds everything together literally. So it now will do, this is a string 1, 2, 3, 10, 3.14 without any spaces. To add spaces, if we wanted to, again, we have to add a space literally by ourselves, like so. And now it will format correctly, which is probably what you wanted. If you didn't want the space, then of course you don't add the space. But that is effectively how you do it. And then if you wanted to go the other way around and convert a string to an integer, you can, but then you might have issues with printing it as through the print command. Cool. There's a couple more types that I want to go through, and we're not going to go through them until a bit later. But I will forget if I don't do it now. So we have what's called data storage types. And they're ways of storing multiple different values in one variable. So you can see here, we've stored my string as being equal to one string in particular. We can use what's called a list to store multiple different values in an order in one variable. And in some programming languages, it's called an array. For Python, it's called a list. So what we're going to do is we're going to say my list is equal to, and we're going to use a square bracket, and we're going to say, let's call this test 1, and then we could even put a number in there. So what I've done is I've created a list, and a list allows you to store multiple things in a particular order in one variable. So and it can also pretty much store whatever you want. You can store text, you can store ints, you can store floats, you can store lists in lists. And all you do is you put your particular thing that you want to put in, then you do a comma, you do the next one, you do a comma, and then on the last one, you just don't put a comma. And then if I was to then print my list, and actually do the thing, you'll see that it prints test 1 and 1. So that's a list, and it's useful for storing multiple things. We'll use it a bit later, but I just wanted to cover it now whilst we were covering different things. And the other important one is what's called a dictionary. So let's say that I had I wanted to know a whole bunch of things about a particular person, like their eye color, their hair color, their height, for example. We could, if we wanted to, use a list, like person equals brown, I don't know, 200 centimeters. I wish I was 200 centimeters. And that would work. But then you'd have to be like, well, what is brown referring to? Is this brown referring to eye color or hair color? Is this brown referring to eye color or hair color? So what we would really want to do here is be able to store values based on a particular key or name. So what we could do is we could say that person is instead equal to, and this time we use a squiggly bracket, and we would do name equals, like, let's say Ari, and then oops, actually I made a mistake. Sorry, this needs to be a string. So name is Ari, height is 200 centimeters, obviously, that's how tall I am. And then eye color is brown. And then we can close it like so. Now you'll notice that the syntax I've used is like a bit more complicated. Like you've got colons, and then you have commas and stuff. For now, just know that this is called a dictionary, and we could refer to these values by the keys that we put. So this is called key value storage, because we have a key and we have a value. We'll come back to it later, and I'll explain how to use it more. I just want to point out that that is a thing that we will be using later. So for now, what I'm going to do is I'm going to delete this. And we are going to, if I remember what we're going to do, yes. So the first thing we're going to do is we're going to create a calculator. It's going to be a very basic calculator that pretty much takes in two numbers, and then it will do all the operations that we want. So we will do things like addition, subtraction, multiplication, division, etc. And so what we're going to do, it's going to be something that I want you guys to work on for about 5 minutes. I'll get you started. So we're going to create a calculator that takes in two numbers and returns all four operators. So addition, subtraction, multiplication, I can't spell, multiplication, division. And so what you're going to do is you're going to take in first number is an input of what is the first number, remembering to put a space at the end so it looks nicer. Second number is what is the second number. And then I want you to basically have it so that each line will do addition, and then first number, oops, that's not what I want, addition, and then first number plus second number, for example. Now that won't work. This code that I've given you has a lot of errors in it. If you can see what they are, that's good. But what I want you to do is to basically go ahead and try yourself to do addition, subtraction, multiplication, division, and if you want exponentials. You'll notice that I haven't told you specifically what the operators are to do this. So my recommendation is what I'm trying to get you to do is to try search it up on Google. So I'm going to give you all about 4 or 5 minutes to try and do it yourself. And when you run into errors, try and fix the errors yourself. So yes, if I get you all to do it for 4 to 5 minutes, that would be mint. And I'll give you an example output so you know what I'm talking about. So I'll just pull up the code that I wrote before. Here we go. So you take two inputs. What's the first number? We'll call it like 4. The next number will be 15. And then it will do this. So this is what you should be getting. You should be getting addition, subtraction, multiplication, division. If you have time, you can also do x to the power, or the first number to the power of the second number, like so. How would you make a large chunk of code inert? Okay, cool. So yeah, in other languages, it's really simple. In Python, for some reason, they're like, yeah, who needs to comment out multiple lines of code easily? I don't know why it's not a thing, but the way to get around it is you can basically wrap your code in 3 single quotation marks, like so. And what this is doing is it will actually turn it into a multi-line string. So this is still part of the string. And this multi-line string, as long as it's not used by anything, it'll basically be the same as a comment. But the compiler will compile it for some stupid reason, as opposed to just being able to, like, have a multi-line comment. But for all intents and purposes, that will be a comment in your code if you wrap it in these 3 single quotation marks, or apostrophes rather. So give you guys a couple more minutes. If you have any issues that you can't seem to resolve, please let me know. All good, Lawrence. I think Amelia might be coming as well, which will be cool. Yeah, so if you're getting that 6 plus 9 equals 69, remember that if you add strings together, you will get that issue. And whilst it might be funny, it is not technically accurate with math. So make sure to try and figure out the way to fix that so that you do not get the issue in that regard. And then in a moment, I will go through and actually explain specifically how to do it. or the way I would recommend doing it. Let's give it one more minute. Someone just joined. I have no idea if that was Amelia. Was that Amelia? Who knows? If it is, say hi. Hello.
Hi.
Hi.
Hello.
There we go. We have another voice. It's not just me talking now. So what I'm just getting them to do is create like a calculator that gives this as the output, or approximately this is the output, as a bit of a programming challenge, and we'll go through it in a second. Cool. So in the interest of not making this thing super long, I might just get started. So first thing that we could do, the first thing you have to consider is that these by default are strings. So input returns a string pretty much all the time. And so when we actually go to put it together like so, we would get it that if we did 6 and 9, and we fix the error that if you get a name error that something is not defined, it's probably because you misspelt or you used a variable that you haven't actually defined before. In this case, it's just that I added a capital letter where there wasn't meant to be. So we did 6 plus 9, we would get addition equals 69, which is obviously funny, but wrong. So what we could do is we could turn this into an int and then plus it as an int. And then if we were to run it, we would get the error that we are then trying to add. Oops, what the heck? Also, you can, if you press Control-C, it'll cancel the current code that you're running, which is what I just did, and it'll give you the keyboard interrupt thing. That'll be useful later when we do something wrong later on. But yeah, if we do that together, we'll get this issue that we can only concatenate the string, not into string, which is the error we had before, which is saying that we're trying to add a string and a number. So we could, hypothetically, wrap everything in a string like that, which would work. But this is very inefficient. And we also would have to do this for every other line, which is not ideal. So what we could do instead is we could actually change the way that we get this input. Instead of having to change everything to an int all the time on every line, we could just do it straight away. So we could change it to an int up here, and we could change it to an int up here. Now, if we weren't sure that we were going to get a number, we wouldn't really be able to do this. And you'd have to check later on to say, is this actually a number that we are expecting? Because we know that we're always going to get numbers here, we can actually just wrap it in int. The problem is that in my hypothetical calculator, I probably also actually want to be able to use decimals, right? I might not want to do 6 and 9. I might want to do 6.9 and 9.6. And if we have it like this, then it won't be particularly happy, because it will say that invalid literal for an integer with base 10, 6.9. Because remember, integers don't allow you to have decimal places. So when you know that you are probably or most likely going to get there's any possibility that you will get a decimal, you're going to have to wrap this in float instead, so that it allows us to accept decimals. Now I can change this code to just be first number plus second number, and make sure to close all the quotations. And when I run it and I do 6.9, I'm going to stop with this terrible joke later on. It works exactly how we would expect. So could someone tell me what why would you ever use int if float is just the same, but it also works with integers? I'll show you. I'll show you exactly why. Just in one sec. With decimals, yeah. So could someone tell me the operator for subtraction, multiplication, and division? Just so that I can see if anyone has learned how to use Google and search for things. So what I'm asking for is what would I replace this plus with to do the rest? Anybody? Yep, so that's subtraction, multiplication, and division. Cool. Now let's say that I didn't actually know. What I would recommend you do is you search for Python and then operators like so. And those things An operator is basically anything that takes an input on the left and an input on the right and does something. So for example, the plus is taking an input on the left and an input on the right and returning the addition of both of those. The equal sign is an operator because it's saying that we're taking input, which is the variable name, and we're taking another input, which is a value, and we're setting the variable to have the value of the thing on the right. So these are called operators, and they're called the same thing pretty much across every other programming language. I can't think of a reason why it wouldn't be. So if you look and search up Python operators, and W3 Schools is an incredible website that has so many programming languages and like really good examples and explanations. So highly recommend W3 Schools. You'll see that there's a list. And what we are using right now is called arithmetic operators because they use numeric values to do stuff. So as we can see, addition is plus, subtraction is minus, multiplication is the asterisk, division is slash, modulus, as it says here, is actually modulo. If you did spec, it's not the absolute function. It returns the remainder, which we'll use in a moment. And then exponentiation is to the power of. So if I wanted to, this is how I would use this cheat sheet like so. And then when I go back to my code, where's my code? If I could then go and do the other thing. So subtraction is the string of first number minus second number. I'm just going to write these all really quickly. Multiplication is first number times the second number. And these operators, especially the math ones, are pretty much the same thing across every programming language. Division would be that one, like so. Now, why is there cases where we would want to use integers as opposed to floats? There's two things. Integers, they take up less space. And they're easier to do operations on. So if you have a really massive program that's going through like thousands and thousands and thousands of numbers, it would possibly be noticeably faster if you could to use integers over floats. But let's say I run this and I have no idea if this is going to give me the issue that I want. I really hope it does. Let's say I give it two decimal places, 4.2 and I don't know, 5.1. So if I pull up a calculator, let's see what the calculator gives me for these values. If the calculator would like to open. There you go, cool. So we put in the numbers 4.2 and 5.1, and it's saying that subtraction is negative 0.89999999995. And you might be like, well, that's not right. It's just negative 0.9. And if we did the multiplication, we would see that it's just 21.42. And if we did the division, it's just, well, the division's actually right. The division is actually a whole bunch of numbers. But you'll notice that for these subtraction and the multiplication, the number itself is wrong. And obviously, if we round it, it's right. But when it actually prints, it's wrong. And this is what's called a floating point error. It's just the way that programming languages do stuff with floats is that you can actually get this issue where it will lose like it'll lose a bit of accuracy very later on. And as a result, it becomes technically the wrong answer. So that's why when you want to use ints as opposed to floats, because even if obviously if you only have integers, it won't give you this error. But if you can use ints, because then you won't get floating point error. If we wanted to, let's say, round so that this doesn't happen and we can get a mostly correct answer, we would use what's called the round function. And it does pretty much exactly what you expect. It rounds a number to the given precision in decimal digits. So if you have a look here, it tells you what inputs it's expecting. It's expecting a number, and it's expecting a number of digits, which is by default nothing. If I was to just round, let's say, And we have to put it inside because it's expecting a number. So we have to put it inside the string because it will output a number. If I was to put it here, and then without giving it a second parameter, which is the number of digits, and to do 4.2 and 5.1, you'll notice that it rounds to 21. So if you don't by default give it any digits or the number of decimal places that you want, it will just round to a whole number. For now, we actually want to, let's do it to like 4 decimal places of something. So make sure that you're actually typing inside the function round. And to put in another parameter, we just use a comma. So now inside, if I was to put it down here, so it's a bit easier, if I was to round the number 4.2999999 to 4 decimal places, I would do a comma and then 4. And that will round it to, I think, 4 decimal places. So over here, we put a 4. And if we run in the code, and remember to save, 4.2, 5.1 is not to 4 decimal places, apologies. It's to the level of precision. So because there's already, it's 4 significant figures, basically. Apologies, that's what it does by default. So if we wanted it to be to like, 8 significant figures, we could put 8 and it would still round pretty much correctly, because once you round the first 8 nines, once you round the first, whole bunch of 9s, it will still round to 42. So that's how you can get past floating point error. Of course, you might then round too much if you don't put enough precision. And if you put too much precision, you might still get the error. Typically, it's not really that big of a deal because you can just look at it and be like, oh yeah, that's clearly, negative 0.9 as opposed to negative 0.899999, et cetera, et cetera. But that's how that could work. For now, we will just leave it as is. It's never faster to press Control-Z when you could just delete it yourself. So I don't know why I keep doing that. And then you just might want to delete all the brackets and then redo it so you have the correct amount of brackets rather than just looking. There's a fast way you can do it. And if I wanted to do to the power of, we could do power is string of first number to and then use 2 asterisks and then the second number, like so. There are other ways you can do it, which may be listed on the Python operator page. Nope, I'm going to go through all that stuff in a sec. Never mind. So ignore me. But there is another way you can do it, which is just writing power or pow and then first number, second number. Does the exact same thing. So up to you. If it's easier to remember that you write pow and then it goes purple, so you're like, oh, that's it. That's how you remember how to do it. Then then that works too. Sorry. So again, 4.2, 5.1, that is the power, and that's pretty much it. So this is a pretty sloppy calculator. It just does everything at once, and it's like, sometimes I really don't care to do things to the power of. I only want to do addition, or I only want to do subtraction. So what we can do is we can actually, in programming, we can tell our code to do things dependent on something else or depending on a particular condition. So what we have in programming is this thing called conditional statements. And conditional statements are basically saying that, if we do something, if something is a certain way or a certain value, then we can execute a particular code. And if it's not that code, then we can do something else. If it's not that particular value, then we can do something else. Recall that if you did methods, and I don't think this is in further, so if you only did further, I do apologize, just stick with me. But remember when we made a piecewise function, and I mean, I can't really write a piecewise function properly, but let's say that we had define f of x as being equal to x plus 1 when x is less than 0, or x plus 2 when x is greater than 0, right? Or we could even say greater than or equal to 0, but I'll get to that in a second as well. So let's say we had a piecewise function like that. Another way we could say it is that the value of f is x plus 1 if x is less than 0, and that the value of f is x plus 2 if x is greater than or equal to 0. So we could rewrite this in code using what's called an if-else statement, or an if-else statement. And if statements are basically the backbone of programming because it allows you to do things dependent on either user input or any random value. And as a result, you can actually make your code a lot more dynamic. So let's say that I wanted to create an if statement that, let's say that we took a parameter called operator, all right? And this is just another input, like what would you like to do? Now, let's say that when I wrote for the operator input, the word addition, I only wanted to do addition. The way I would go about this is by using an if statement. So what I would write is if then operator is equal to, let's say, addition, and then colon. So there's a lot of things going on here, and I'll try and explain them. The first thing is that there's actually a type that there's a data type that I keep forgetting to say every single time called a Boolean. And a Boolean has two values. It's either true or false, or a 1 or a 0. So when we write a Boolean, we write it with a capital letter, and it's true or it's false, one or the other. Now, a true value is when something, I can't really explain what a true versus a false is. You should know. If anyone doesn't understand the difference between true and false, like true being yes and false being no, that's I'm not entirely sure how to actually explain it. But you just got to remember that if something is true, then the code is basically saying yes. And if something is false, then the code is basically saying no. So what happens is with an if statement, the if statement is saying if, and then I'll just write it down here. If condition is true, then it will execute code. So you'll notice a couple of things. Firstly, when I pressed enter, or if you press enter, it's automatically putting my cursor 4 spaces in front of where normally I'm typing. In Python, Python is called a white space based language. This stuff over here that is white and has a lot of spaces is called white space. And it's basically saying that it tells the code that the block of text, the block of code that we're about to execute belongs to the above statement. So here, if this whatever condition here is true, then this code would be run. If I was to then have some more code here, then if this condition was true, because there's white space here, and by default, it's a tab. Like if you press the tab button, it will automatically move 1 space ahead, or 1 indent ahead, as I'll probably refer to it. It's also 4 spaces. Like if you press space 4 times, that's the amount of space that you would use for 1 indent. My recommendation is to use the tab button because it's just the way that everyone does. So if this condition here was true, then it would execute this code. But because there's no white space on this some more code here line, even if this condition was false and this block of code did not execute, this code at the bottom would, because it doesn't belong to the if statement. If I was to instead add a tab at the beginning of this line, then this second line now belongs to the if statement. And as a result, it will only be executed if this condition is true. Does everyone kind of understand where I'm going with this? That because of depending on the white space, it will execute only sometimes if it's in the if statement or not. We could, if we wanted to have another condition, we could technically write if second condition, I can't spell, is true, and then execute some other code. Now we could do this, and this would work, and this would be completely fine. By the way, to say that an if statement is done, like you're no longer referring to this if statement anymore, you just have to have code that has the same amount of white space as the if statement as before. So if I was to put code here and say, do stuff here, I couldn't then put more code here. I couldn't then put more code here and expect it to work in the if statement, in the above if statement. It will error out because it's like, why is there white space here if there's no condition statement up here? So I could do this. I could have one if statement If this is true, do this. If a second condition is true, do this. And this is useful anytime that you want something to be running independent of other if statements. So in my particular example, I might want this code to execute if this condition is true, and regardless of if this condition is true or not, to check if this is true and as a result run it. But sometimes there are times where you only want an if statement to run one thing at a time. For example, if my operator was addition, then there's no reason that my operator would ever at the same time be subtraction. It wouldn't make sense. You can't do addition. Like, we're not going to say addition or subtraction. It's just going to be, you can only write one operator. So firstly, I'm just going to finish this, and I'm going to say, actually, wait, let me go over this for a sec. What should I do first? Yeah. So over in our line, the actual line of code that we will be using, we have if operator equals addition. And you'll notice that it's a double equal. The reason that it's a double equal is because the way that we define variables is with one equal. And as a result, we can't do like if operator equals addition like this, because then the code will be like, wait, why are you trying to do an if statement, but then also saying the value of operator to be equal to addition? So you can't do that. Whenever you're doing comparison, and I'll just go over here to have a look at the Python comparison operators. So it's used to compare two values. Equals is if you're trying to check if something is equal to something else. Exclamation mark equals is not equal, which is basically the opposite, checking that something is not equal to something else. Then you have greater than, less than, greater than or equal, or less than to equal. So if we go back to the code here, we can say that if operator equals addition, so we're saying if operator is equal to addition, then we could copy paste our code up here. I'll cut it, put our code up here, and it will then, if we then run the code and we do, the first number is 4, the second number is 5. What would I like to do? If I did addition, it will do addition. Ignore the rest of the code. But if I do it so that it's 4, 5, and I just do like whatever, something that's not addition, you'll notice that addition doesn't show up in the list, because when it checks if operator is equal to addition, it says, well, SFSGF is not equal to the string addition. And as a result, it doesn't execute this code. Give me literally 1 second. I'm just going to close my door because other people are home, so I don't want to annoy them. Okay, cool. So that's how an if statement works. Something to point out is that when you do an if statement, for something to be equal, it also has to be the same type. So for example, if I was to write if first number was equal to 10, like so. Now 10 itself, we've defined it as a string, but first number over here is defined as a float. If I was to write print it's true here, which is a way of knowing if the if statement is actually executed just by printing something. If I was to go over here and I was to run the code and to put the first number as 10, what do you guys think would happen? Firstly, it gave me an invalid syntax error because I forgot to do 2 equals, which was not what I was trying to ask. But anyway, so if I run this code and I put the number 10, anybody, it would never print. Yeah. So if I do this and it doesn't matter what I do, it won't print, because even though first number is 10, the actual value that we're comparing it to is the wrong type. So if I was to change this to 10 without the quotation marks like so, and do 10, 5, and then whatever, it would say it's true, which makes sense. It's just something to point out. And especially when you like don't automatically change it to like a number, it can sometimes trip you up that you're like, oh, wait, I'm actually comparing a string to a number. So sometimes you just have to go through your code and be like, okay, if this number is a float, so I need to make sure I'm comparing it to actual numbers. You'll notice that 10 itself is an integer, but we're comparing it to a float. That's usually okay. Comparing different types of numbers is fine, but you can't really compare a string to a number. Cool. So now we want to go and do the rest of our operators. What we could do is we could do and the exact same thing, right? If operator equals subtraction, and then print the line. We could do that and it would work, but it's not efficient. And when you're only doing stuff like this, when it's just a very, very small program, efficiency isn't really an issue unless your lecture is actually about writing efficient code. But when you're going into much, much bigger programs, you want to always try and make things as efficient as you can. Otherwise, your code will lag. So what we can do instead is we can use what's called an else if statement. And an else if does pretty much exactly what it says. It's saying, if this first statement is not true, then it will check if the second statement is true. So if I go over here and I have this if statement and it does stuff, so we'll just bring this second if statement all the way down here. So if we have this first thing and it's checking if operator is equal to subtraction, it will do stuff. If it's not equal to subtraction, then what we can do is we can check to see if it is something else. And the way we would write this, the way that you would instinctively write this is else if, which is fine in some programming languages. For some reason, Python was like, nah, we're not going to do it that way. And they got rid of the S and E and they put it as elif. This is like the one annoying thing about Python that I always forget the first time when I come back to it, that their else if statement is actually elif, like that. So else if, we can then put another condition to check. So we could put operator is equal to multiplication, for example. And the reason that we would want to use else if statements is because if the operator was equal to subtraction, we know for a fact that the operator can never be multiplication. And so we don't want to actually run that code because we know that we've already found one condition that's true. And as a result, we don't need to check for any other conditions. So if I go back here and I bring this code back up, I need to firstly change this to an elif, because if the operator is addition, we know we're never going to want to do subtraction or multiplication. Another thing is you can't, this will error out because you have to have a proper line of code when you have like an else if statement in each like block. So I need to actually copy this across. The comment won't count. Oops, I was about to paste it. So we're going to do this like so. We can get rid of the does stuff. And we can do the same thing for the rest. Remembering we write elif and we do operator equals division and copy it like so. Let's say, for example, that when I copy pasted the code or I wrote the code by mistake, it looked like this. So we have an extra indent. This won't work because Python literally is so picky, like it will not function if you do not have the right space. The right amount of white space. But let's say that we had something like, that's not what I wanted to do. Let's say we had something like this. There's a couple of ways. In fact, no, that's really annoying me. Let me like do this. So there's a couple of ways that we can fix our code. And this is just a handy feature. But if all of this code is in the wrong spot and we need to like move it either forwards or backwards, you can use the key control and then bracket to move it either way. So just have a try on different lines. And if you hover, if you select all the code and then move it forwards and backwards like that, it's just an easy way to move it forwards and backwards so you have the right amount of white space. Just a bit of a side note, doesn't actually matter. You can also just go to the front of the line and press delete, like backspace, and it will delete the amount of, it'll delete one tab. Yeah, square brackets. Yes, apologies. Thank you. By square brackets, I mean these ones or these ones, not yes, not those ones. Apologies. Thank you for that clarification. And then we could do one more. If operator is equal to power, we can do this. So now what we've done is we've separated all of our code into an if, else, if statement. And if we run the code now, we can do 10, 5, division, and it will do only the thing that we've told to do. However, what if we are very silly and we're like, well, I actually want to do square roots. Nothing happens because we haven't told it that square root is an operator that we can actually use. Now, we could go and add every single type of operator, which you totally could, but that's pretty boring. That's not what we're going to do. What we're going to do is we're going to create a case or like another statement to say that if nothing above us is true, to do this code. And this is called an else statement. And this entire thing itself is usually called if else because of it. So what an else statement does is you write else and you can't have a condition because the condition for an else statement to run is that nothing above it has run. And we could say print unknown operator. And what this is saying is, if the operator isn't addition or subtraction or multiplication or division or power, it will run this code. So now if we rerun the same code we just did, and we did square root, it'll say unknown operator. So obviously you can't have an else if without an if, and you can't have an else without an if. It's just a thing, like if you can't go all the way over here and just be like, else, but there's no if statement. Like what are you doing? So you require an if to be able to use else if and else. You also can't have multiple elses like so, because like then this would never run because the else would always run. So you just can only have an else statement, one else statement, and you also can't put an else if below an else. Because the else statement is effectively closing the if statement because there isn't it won't check anything else. And as a result, this elif statement will be like, there's no if above me. That is a bit confusing. If you want me to clarify what I just said, someone let me know. But basically you have an if statement, you then have as many else ifs as you wish. You can then put an else, but then after you put the else, it's done and you can't put anything else. I can't put anything else. Yeah. So this is how you use if statements. Let's say that we actually wanted to be able to not in this particular case, but we wanted to be able to have things run independently. So even if the operator was addition, something else could still happen. Then you would just replace the elif with if, and it would check it itself. It would check it all the time, regardless of whether or not the above if statement has done, which is what I said earlier. Something else you can do to get a bit more specific with your logic is you can do this thing called nesting. And nesting is basically when you put an if statement in an if statement. So let's say I wanted to know if we wanted to do addition, but we also wanted to know if the first number was 1 or if the first number was 2. So let's say that we do if the operator is addition, we're going to create a new line. And we're going to do another if statement. And we're going to say that if first number is equal to 1, we can then say print it's 1. Oops, and we remember to close things. And then we could say elif first number is 2, print it's 2. And then so that we can, have every other case, we could write else print it's not 1 or 2. And what we're basically doing here is we're just saying that if the operator is addition, we do another check. So then we do, if this is true, print 1, or print it's 1. If it's 2, print it's 2. Otherwise, print it's not 1 or 2. And the white spacing is really important. You have to have the exact amount of white space. If you have this white space, if you don't have the white space here, for example, it'll error out because because this if statement doesn't have any code. And it will also error out because this else if doesn't have an if because this is canceling it. Once you mess around, that'll become a bit more clear. But basically, always make sure you have the right amount of white space between your if statements. You've got to have exactly one tab. So now if I run this code and I go 1, 2, and addition, it'll print it's 1 because the operator was addition and then the first number was 1. So that's how you can do nesting. Let's say that instead of doing it like this, I wanted to only print addition if we were doing addition and the number was 1. So what we could do is we could write it as this. We could nest it and say if first number, if first number is equal to 1, then we could do then we would print the statement, and we've got to make sure we get the right things. So now what we're doing, and this is just what I'm trying to explain how to do. This is not the way to do it, and I'm going to explain the best way to do it in a second. But now if we were to print the first number as 1, the second number is like whatever, and we did addition, it would print the addition line. But if I was to then do 5 whatever and addition, it wouldn't print the line because addition, whilst the operator is addition, the first number is not addition, and so it doesn't run. Now you can do this, but there is a better way that's also more clear and just neater to do to write this exact same code. So if I get rid of this if statement and I move this back and I go back to the Python operators, we can look at these things called logical operators. And logical operators are used to combine conditional statements together. So basically, instead of nesting the 2 statements together, we can combine them into 1. And these are pretty like self-explanatory. We have and, which returns true if both statements are true. We have or, if returns true if one of the statements is true. And we have not, which does the complete opposite. So basically, we have, if we were using and, we would have to have that true and true, or I should even just do true and true is true, but true and false is false because both of the statements aren't true. True or true is true. True or false is also true because one of the values are true. And false or false is false. We can also use not to do the opposite. So if I was to say not, and you use a bracket to determine, like you use a bracket to say what you are using not on, then not false or false is true because the false or false itself is false and not does the opposite. So it returns it as true. Similarly, if I was to do a not over here, not true and true, because we have 2 true values and we're using and, the actual bracket itself is true, not does the opposite, this becomes false. So that's how you can use a couple of conditional operators. Logical operators. And so I'll leave that there for a second. So we could go back up here and we could say, if the operator was equal to addition and first number was equal to 1, then we could do this. I'm just going to put these in a comment like so, just so that the code will compile. So if I say that first number is 1 and the second number is whatever, and it's addition, it'll run. And if I do it again, but I don't put the first number as 1, I do addition, it won't work. And it will say unknown operator. And I was like, wait, what the hell? Because now that we've done this, now that it doesn't know that, now that this if statement isn't running because of the and the first number is not true, it's like, well, none of these are true. And so it does unknown operator. Obviously, we don't want our actual calculator to run this way. This is just an example. And you can do whatever you want in pretty much every conditional statement. Like you do or I don't know, like, or second number is 3 or 45. So just hit 45, which would be a pretty terrible calculator because whenever you use the number 45, it would do subtraction even if you didn't want to. Because it would check, okay, is our operator subtraction? Let's say it wasn't, it'd be false. Or the second number is 45. So if the number was 45, this is false, but this is true. And because of the or, it makes this entire statement true. And as a result, this block of code runs. Obviously, that's terrible for an actual calculator, but that's just how conditional logic would run. So now that we've done that, that's pretty much all I have to explain about if statements and stuff. I think, let me double check. Yep, I think that is pretty much it. Cool. So The next thing we're going to do is talk very, very briefly about modules and importing stuff, only because I need to import one thing in particular. So if you guys want, I'm gonna delete all this code. You guys can like comment it out or something if you want. I'm just going to delete it for the sake of making it a bit more just neat to look at. So I'm going to delete this quickly. And what we're going to do is I'm going to search up Python how to make a random number. You can see I've searched all these things up yesterday. So the very first thing is how to generate a random number in Python. And just to be clear, the thing that we are going to do is we're going to create like a game that you have to guess a number and it tells you if your guess is higher or lower than the actual value. So that's what we're going to work towards now. So this page, this random page, the first thing I found on Google is how to generate random numbers in Python. Now you can read all of this. Usually the first like block of text is completely useless and them just talking about stuff that's not relevant. So we can keep scrolling down until we find some actual code. And we're like, oh, here we go. We found some code. And we can seed it. If you know what a seed is, it's basically the way that it randomly generates things. A computer never actually properly randomly generates numbers. It's just not possible. The computer generates things based on like a seed or the way it's programmed, and it's called pseudo-random. As it says here, it will see the pseudo-random number generator. For now, we don't really care. We just want a number. It doesn't really matter if it's not really randomized. Now, for our game, we're only going to use integers because good luck guessing the number, 0.1343642 without losing your sanity. So we're only going to be guessing like whole numbers. So we're going to keep scrolling, and you could read this all. I tend to just flip a few pages really obnoxiously until I find the code I'm looking for. So we have random integer values, which is what we actually want. So the random integer values can be generated with the randint function. This function takes two arguments, the start and the end of the range for the generated integer values. Random integers are generated within and including the start and end of range values, specifically in the intervals start to end. That's a pretty important clarification in programming, and we'll get to it a bit later on, that things usually generate from the first number to the second number, not including the second number, which is why you got to actually read what's going on, because in this case, it does generate from the first number to the second number. So random values are drawn from a uniform distribution. We don't really care. The example below generates 10 random integer values between 0 and 10. So what I'm going to do is, because this is really annoying, I'm just going to copy paste it into Python. So, oops, I have someone managed to copy it twice. Okay. So what's going on here is the most important thing to notice is what's going on in this very first line. In fact, we're going to get rid of this line. We don't need this. The seeding process is completely wrong in this example, but whatever. So generate random integer values. What's going on is that this line of code is doing two things. Firstly, it's importing a module called random, which is built into Python. So from random means that we're importing a module called random. And it does pretty much exactly what you would expect. It allows us to generate things randomly or pseudo-randomly. And then import randint is not really that important. It just, once you get into like programming, you'll understand specifically why we do this. But all it's saying is from random, we're going to only import the function called randint. So import randint would specifically import the function called randint so we can use it. Like so. When you put it all together, you get this line. And because this will actually error out, I'm just going to comment it, but I just wanted to explain what's going on. You don't really need to worry too much about knowing how to import modules, like what modules there are at the moment. Once you start actually programming in uni, if you are, you'll be told specifically what modules to use. But if I search up quickly Python random module, then you'll see that there's a whole documentation page about the random module. We won't look through any of it. I'm just letting you know that it's existing. So if you need to figure out specifically like what type of random function you want, the list is there, and what they do is there as well. Cool. So the next thing it does is it does for this in range 10, and we'll get to this in a moment. In fact, I'm just going to get rid of that because that's kind of whatever. And then we're setting the value, the variable called value, to be equal to the output of Randint 0 to 10, and then we will print the value. Now, as it said in the documentation here, it generates numbers between the interval start and end inclusive. So when we go and run the code, we save it, you can see it generates 3, 5, 3, 4, 7, 6, 4. Will it ever print 0? There's a 10. Anyway, it's not, you'll see that a couple of numbers like 6 are coming up a lot more often than others. It's just kind of how the whole seeding process works, that it doesn't actually seed, like it doesn't generate numbers properly. So certain numbers come up more often than others. It is just a byproduct of how programming works. There are ways around it. We don't need to know. We don't actually need to care right now. Will the university teach us again the basics of Python like this? I suspect so. If you're doing things like Fit 1045, I suspect so. This is just so that you guys get an understanding of what's going on, so it doesn't become so overwhelming. It will probably go into the university will probably teach you this stuff, because if you don't know it, they have to teach you, since you're not expected to know how to program before you go. So we have something like this, and this is generating a random number for us. So what we now want to do is we want to, we're still not getting a 0, so it's not particularly very random, but anyway. And what we want to do is we want to go and we want to start creating our game. So the first thing we're going to need to do is to take a guess, a guess value from the person playing the game. So if you remember, the way that we get a value from a user is we say that the variable name is equal to the input of what is your guess, right? If we print, we don't even need to print, but when we do this, we can say our guess is 51 or something. Obviously, nothing happens because we haven't told it to do anything. I'll also just increase the guess, the random integer generation from 1 to 100. So our game we'll have to guess a number between 1 and 100. So now what we can do is we can use our knowledge of if statements and logical operators to actually tell us if our guess is higher or lower than what the actual value is. So I'll just rename value to be correct value, just so that we don't mistake it later on. So now what I want you guys to do is I want you to use the if statements and use the comparison operators. And I want you to say that if our guess is less than the actual correct value, to then print higher. And if the value is, if our guess is greater than the correct value, then it should print lower. And if it's correct, I want you to print you got it right. So if everyone could just take 1 minute to use the if statements and to use the comparison operators to create that code very, very quickly. As I grab. And if at first you're like, "Ooh, I don't know what's really going on," it's fine. Things like programming do take time. We're going pretty fast as well through a whole bunch of stuff. So if you're like, "Oh, I don't know exactly what I'm doing right now," that is all good. I'll give you 30 more seconds and then we'll go over it. All right. So like I said before, if we want the value, if our guess is lower than the actual value, we want to print higher. So we can say that if something I did forget to do is I need to actually change this to an integer before I forget. This is one of the cases where we know we're only going to get whole numbers, so we can just say it's an integer as opposed to a float, which I would recommend. So if our guess is less than correct value, we're going to print higher. And then we know that if the guess is less than correct value, there's no other like statement, so we can use elif as opposed to doing another if statement by itself. So if guess is greater than correct value, we can say lower. And otherwise, if it's not higher and it's not lower, we know it's the correct value. So we say else print you got it right. So now we can run the code and we can say, all right, well, we know that the actual answer is 20. Let's say that we guess 50 and it tells us we have to go lower. We do it the other way around. We say the actual answer is 31. So we write 15, we get higher. And if we get it exactly right, it says you got it right. Now, obviously this game is, pretty hard because you have literally one guess to get it right. Otherwise the code just executes. And if we didn't actually know what the value was, it would literally be a 1 in 100 chance of getting it right every time you run. That's not a very fun game. What we really want to be able to do is to be able to keep playing until we get it right, which is what we're going to implement. So if we have this code, we can leave it for now and we'll come back to it in a second. What we need to now go over is what's called a loop. And in pretty much every programming language, there is very many different types of loops. There are many in Python. I'll go over, I think, the two most common ones. And a loop does pretty much exactly what it sounds like. It runs code and it keeps running code until a specific condition is met. So there's two different types of loops, and we're going to search up Python loops. And you'll see that there is, the first thing that pops up is a Python for loop. This isn't what I was really hoping for. I was hoping it would show us both, but it's not. The other one is called a while loop. So we'll go back and I will just ignore that for now. So the first type of loop that we're going to cover is called a while loop. And what it does exactly what it sounds like. While something is true, it will execute code. So for example, while our guess is not correct, it will continue looping. So the way that we write it is while condition is true. I misspelled condition, but it doesn't really matter. While condition is true, execute code. And it will keep looping anything that's within the certain amount of white space. So this will be part of the while. This is not part of the while. So it will keep looping that code up until the point where the condition is false. Whilst it's looping, everything under the while statement will also not run. So if the condition is true, this line here will not run. As soon as the condition is false, this condition will then start running. So we're going to use that. We're going to use this while loop to keep guessing. So we have guess equals input. What is your guess? Now what we're going to do is we're going to use a while loop so that our game keeps looping over and over. So we're going to write while guess is not equal to correct value. And we need to bring all of this into a one more indent, because now we can see it wants the indent there. So we're going to highlight it all and press tab, and then it's in the correct indent. Now, what's the issue? Now, sorry, whenever you have a loop, it's really important to make sure that you don't get what's called an infinite loop. And an infinite loop is when the thing that you're checking to see if the loop will execute can never change or will never change in a particular case. So you'll notice that if I run this code, I put the guess is 50, it starts spamming my console with the word higher. What I've done is I've created an infinite loop, and because of it, the program will never execute. In order to cancel the code, you press Control-C, or I assume it's Command-C if you're on Mac, and it will interrupt the code and cancel anything that's running, and you get the keyboard interrupt thing. So if you've done that, you press Control or Command-C, and you will interrupt the code. So could someone tell me why this while loop is an infinite loop? Why can we never get out of the loop? And if you're not sure, just take a guess. It's usually how programming works as well. You just guess things until you get it right. The number stored in guess never changes. Yeah, exactly. So this is a common mistake that people make, including me, all the time. And what happens is that you forget to change the actual variables that you want to check, that are being checked. So what we need to do is we need to reset the value of guess. And the best way to do that is just by literally rerunning the exact same line of code in the while statement like this. And so now what will happen is when I put my guess, let's say I did 50, it'll ask me for the exact same thing again, and it won't infinitely loop. And if I go 40, it'll keep saying. And when I eventually put 11 in, it will stop. So it'll stop and it won't say anything. What we could write is we could say at the very end, outside of the while statement, we could write print, congrats, you got it right. And now when we run it, and we do 64, because we're incredible and we guess it the first time, it says, congrats, you got it right, and it stops the code. So that's an important thing to remember, to actually change the value so that you don't get an infinite loop. And it's really easy to tell if something's infinitely looping if you just keep printing something over and over again, like, well, that shouldn't be printing all the time. So that's a while loop, and that will pretty much work the entire time. Another thing we could do is another type of loop is a for loop, and a for loop does this thing called iterating, which is like going over each value one by one of a particular thing. Recall earlier that we said that a list is like this, like it can be whatever values you want, and it allows you to store multiple values within one list in one variable. What we could do is we could iterate over each of these values in a list by writing for, then like value in my list. So value itself becomes a variable that is changed every time the loop finishes. And it's like for like list value of something, right? I could then do print my list, print list value, like so. Ignore the fact that I haven't used the proper capitalization technique. It doesn't really matter. I am just going to quickly comment all this other stuff, all this other code out. And you'll notice that when I run this code, it prints each thing one by one. Because what it's doing is it's saying, all right, for every value in my list, run this code. So at first, the list value is equal to test, it prints test. The next time it loops, it's potato, it prints potato. And next time it's 45, it prints 45. So that's a way you can iterate over a list. You can also do the same thing with numbers to run things a certain number of times. And we replace my list with this thing called range. And this is a really weird way of doing it, admittedly, compared to other programming languages. When you use other languages, they have a method called like for I equals 0. And if you mess around with another language, you'll see when you search up for loop. But the way that Python does it is they do full list value in range. And then when I open up the bracket, you'll see that it says range stop or range start stop step. What this is saying is that Python can accept different amounts of parameters. And the first one is you input only one parameter, which will tell you the stopping number. Sorry, the stopping point, not the stopping number. And the other one is that range, you could do start, stop, and then the brackets means it's also optional, which is step. Let's say that we don't know how range works. We're going to search up Python range, like so. For example, this creates a sequence of numbers from 0 to 5 and prints each item in the sequence. X equals range 6, or they could just write for n in range 6. Something important to point out is that, well, hang on, when we put range 6, why is it printing from 0 to 5? This is an important thing to note in pretty much in most programming languages, and there are some exceptions, but the most basic ones, when you consider the number that stuff starts at, like for example, if I was to have a string like test, the first value in like a string or in a list, like this value here, it's referenced by 0, not by 1. So although we could say that the first letter is in test is T, in programming, it actually starts, everything is referred to in as 0 being the start. So this is, and it's called the index. So the 0th index of this list is test. Even though it's the first value, the actual index is test. Now, if this is confusing, let me know and I'll try and explain it better. But the 0th index of test is the first number. So it's the same thing with the range thing. The first number is actually 0, and it goes up, and the number that you input for range is actually the number of numbers that you want, at least when you just do it like this. So it will go up to the number, but not included at the very end. So obviously 0 to 5 is 0, 1, 2, 3, 4, 5, which is 6 numbers, but it actually starts at 0 and it goes to 5. This is something that confuses absolutely everyone. It confused me, and I always did it wrong the first time. And you'll be like, "Wow, why is my number not going up to the values that I want?" And you'll be because it starts at 0 and it goes to, but doesn't include the number for stop. Over here, you can see that there's another syntax which has start, an integer number specifying at the position to start. By default, it's 0. The stop is an integer number specifying at what position to stop, which is not included. And then step is like how much you increase each loop by. By default, it's 1. You could do it by like 2, and then it would jump from like 0, 2, 4, 6, 8. For now, we don't really need to care about that. So I just wanted to let you know that like if you were to do this, for example, for list value in range 6, print list value, that will print the numbers 0 through 5. If I was to do from like 1 to 7, now I've added an extra parameter, which is the starting parameter, and it prints from 1 to 6. Remembering that it starts at the first value, but it goes up to, but not including the second value. And if I was to put, for example, the third parameter, which was the step amount, which in this case is 2, it'll do 1, 3, 5. It'll say, well, 7 is the next value, but 7 is, this number isn't included, so it ignores the number 7 and it only prints 1, 3, 5. Yeah, so those are different types of loops, and loops are helpful. They're not really helpful in this particular example, at least not these ones. We only want to use the while loop, but if you want to iterate over a whole bunch of stuff, that's how you do it. Let's say that I delete this code and I bring back our other code, and we wanted to actually be able to know, like for fun, at the very end, we wanted to know what our guesses were in the order that we guessed them, so that we can see, how many, how well we did with our particular code. Now, what we could do, and this is a very, very bad method, but we could say that, first guess was equal to a number, and then second guess was equal to a number, and third guess would be equal to a number, and fourth guess would be equal to a number. And every time that we made a guess, we'd set the value first guess and second guess and third guess and fourth guess, etc., 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 on and on and on, We could do that. And that's a terribly inefficient way. And let's say that someone's really, really bad at this game and needs like 1,000 guesses. You would have to have 1,000 different variables. Because we want to be able to instead store lots of different values easily, we use what we used earlier, which was a list. Remembering that a list is like this, is like that. So what we can use is we're going to create a list. And we're going to create a new list at the very beginning before we use our while loop. And we're going to do our guesses is equal to an empty list. The reason that we need to create the empty list before we do the while loop is if we put this line of code here, every time the loop starts, it would just create the list. It would make the list empty again. So always remember that if you're going to create something, to initialize it, as it's called, before you would ever actually like loop around or affect it. So what you usually do with programming stuff like this is whenever you're going to create a variable and you know you're going to use it, you just chuck it at the very top of the program or towards the top, underneath usually the from statements. So that it gets initialized and you don't accidentally keep resetting it over and over. So what we want to do is every time we add a guess, we're going to want to add the value to the list. Now, the way you do this is called appending, but it's different for every language and it's different for different things. Like in a dictionary, it works differently. A dictionary is the thing we talked about earlier as well. So what we're going to search up is we're going to search up Python, how to add a value to a list. Methods to add elements to list in Python. And we can click on this. And this is a very easy image that tells us everything. So Python add to list, append the object to the end of the list. Because we probably want to see the guesses in order, we might as well use append. There are other things. Extend, I didn't even know that was a thing. Inserts at a particular point, but for now we're going to use append. And append simply adds things at the end of the list. So how we do this is, in fact, it's probably easier if I find an actual bit of code that says exactly how to do it here. Oh God. Here, just ignore every line of code except for this line here. You'll see that they create a list called fruits. And you'll see that here they change fruits by writing fruits.appendf. And the reason that they're doing it like that is because they're saying that the fruit list has particular things that can be used to change it. And it's every different data type has particular functions that are built into it that allow specific functions to be called on it. In this case, lists have a function called append. So what we have to do is we have to write our guesses dot append, and then we open the function, and we, in this case, let's add guess, like so. So the reason that we have to do dot append is because we're saying, all right, we are referring to our list, which we define up here, and the list data type has a function called append, which adds a value at the very end of it. So if you forget how to do this, it's just a matter of searching it up and seeing the way you're supposed to do it. The reason that we don't have something dot print is because print is just a general function. Our guesses is a list, and so we have to refer to the list and then the function we want to act on it, which in this case is append. So now we can do that. So now every time we guess, the guess that we add will be added to our list. At the very end, we might want to say, print all of our guesses. And here's the thing: if I do plus our guesses, my guess, is that it would actually error out once we get to the particular code. And sometimes it won't error out until you actually run this particular code. So if I did 32, 31, and then 33, it'll error out and it says can only concatenate string, not list to string. So we just have to turn this into a string. This happens all the time in Python. A lot of other programming languages will just be like, yeah, whatever. We'll just turn it into a string for you. Python does not. So it's a bit annoying. We can just make a couple of random guesses. We guess 73, and it will tell us the guesses that we did. So what this has done, it is added every time we've made a guess to the very thing. It's added it to the list. And you'll notice that the last guess, which was 73, is not on the list. The reason is because we add our guesses at the very beginning of the loop. But when we get the guess right, we only change our value of guess here. And then the while loop will be like, okay, you got it right. So we won't run any of this code. And as a result, it doesn't add it. You could get around this by putting the guess over here, like this line of code over here. But then the first time through, it wouldn't run. And so you'd be missing the first line of code. And so to fix that, you would have to put the code like here to add the first value and then in the loop. That's pretty complicated. For now, it doesn't really matter. Just we can ignore the very last value, whatever, it is what it is. You could also actually put the line of code here as well, and that would work. So that's how we can look at, so we can add stuff to lists. There's things like sorting lists. You can reverse them. You can add stuff to them in really specific ways. For now, all we need to know is that we can add a value to a list. And the next thing that I'm going to say is you can also get specific values from the list. The rest of the stuff about lists and stuff, we just will ignore for now. Once you actually start programming at uni, you'll probably have to use it. But just so that you understand that a list is an ordered set of values. So the order 7141 is very particular. And because it's particular, we can then refer to it. We can refer to specific values. So the way that you refer to a specific value in something like a list or a string is you put the variable name, you do an open square bracket, and you do the index of the value that you want to get, remembering that indexes start at 0. So the guess, for example, the guess 71 is at index 0. If I put 0 here and I print this, it will print the very first value in the list. So if I was to guess, there we go, we got 1. So I'll go 2, 3, 4, and then I'll guess 1. You'll see that it prints 2 because the very first index, which is at index 0, is the first value, which is a 2. If I change it to a 1, it'll print 3 in this case. And if I change it to a 2, it'll print the number 4. Let's say that I do our guess is 5. And I do 50 and then 92. It gives an error saying index error, list index out of range. And this is just another error I want to point out. It's because you're trying to access the value at index 5, which is the 6th value, but we only actually have pretty much one value. And because of it, it errors out. It's just something to be aware of, that you can't, if you refer to an index that doesn't exist, it will error out. We can also do the same thing with strings. So for example, if I was to do, test and then an open bracket and then put 0, oops, don't do that. And then I guess 78, oops, you got right at the right point. You'll see that it says T. Because the first index, which is the first value, in this case, is a T. So that's how you can refer to values in indexes, in strings. And yeah, that's just the way that you refer to it. And it's pretty much the same in most programming languages as well. So I just wanted to point that out as well. The last thing that I think we're going to do, being where this has gone on for quite a while, is we'll look at functions. Yeah. So you'll note that things like print and append and input and int are all built-in functions. However, we can actually define our own functions, which we can then call later on in our own code. So remembering that in CAS, define f of x equals x plus 1. We are defining a function on our CAS at least, with the name f, input parameter is x, and then the output is x plus 1. In Python, the way that we define a function is very similar. We write we write def for define. We then put the name of our function, which will in this case, we'll write our function. We'll open a bracket. We'll put the name of our input parameter, which can be anything we want, and it doesn't have to be the same thing that we give it in. The only thing that matters is the order of parameters. So let's say we do our function, and we'll write guess and value. In fact, no, we'll do correct value, like so. So now what we're doing is we're defining our own function. And what we're going to do is we're going to just copy paste this code in from above, this higher low, you got to write code, like so, and we're going to copy it into here. Now what we can do is we can call this function wherever we want in the code. Now, typically, the reason you would want to use a function is if you're going to use the code multiple times. In this particular code snippet, we're not going to use it multiple times. We're only going to use it once. But usually, you would want to create a function wherever you're going to use the exact same code multiple times over and over. So in this case, let's say we write, we just call it the exact same way that we would call it normally, our function guess correct value. Now, let's say that these variables weren't called guess and correct value. The only thing that would matter is that they're stored in the correct order. They're given in the correct order. So if this was renamed anything else, as long as we put our guess in first, our correct value in second, it would work as expected. So we can do this. Now, let's say that, let's say that we run this code and we get rid of all this stuff and we run the code. And we guess 62. You'll see that we have an error that says name error. Name our function is not defined, which is basically saying that we're trying to call something that it doesn't exist. Most programming languages, including Python, run code in a certain way. They start at the very top, they read down, and they run as they go downwards. Because our while loop comes before our function definition, when it calls our function, it has already read all the code above it, but it doesn't know what our function is because our function is below it. So whenever you define a function, 9 times out of 10, you would always want to bring it to towards the top of the file. So now when it reads the code, it'll be like, okay, I'm reading. Oh, there's a function definition here called our function. And then when it comes down over here, it's like, oh, I know what our function is. And as a result, when we guess 55, it works. When we guess 100, it works. So as a result, whenever you define a function, you should always put it at the top. The last thing I want to just quickly point out is that similar to how things like input return a value. So for example, when we call input, it will return the value that we have written into the console. We can also return things in our own functions. Let's say that we wanted to return the difference between the guess and the correct value. So by the difference, I also mean like a positive difference. So if let's say that our guess was 30, let's say our guess was 10 and the correct answer was 40. We'd want it to say that the difference is 30, but also if the guess was 40, if our guess was 40 and the correct value is 10, we also want it to return 30. And to do this, we use what's called the absolute function. If you did Spanish, you'll know what it is, but basically it turns a negative number into a positive number. That's pretty much all we need to know about it. So to return a value, we simply type return. We type return, and then we can put what we want to return. In this case, we want to use absolute, which is called abs, and it returns the absolute value of the argument. And all we're going to do is we're going to do guess minus correct value. If you don't really understand what absolute does, it doesn't really matter. Just know that we are returning the difference between guess and correct value. Now that we've put a return value into our function, we can then actually refer to it in the rest of our code where we call it. So similarly to how we do guess equals input, like this, we can now say that the difference is equal to the output of our function. And if we then go print difference, like so, we go 40, it returns 50. If we do 40, if we do 30, it returns 60. So you can see that what we've done is we've actually made a function that can return a value, and then we can actually use that function and use the returned value later on in our code. So that's how functions work. There's ways of making like optional arguments, which we're not going to get into, but you can. And a whole bunch of other stuff you can do. But at a very, very basic level, that's pretty much it with functions. Overall, the only other thing that I would go over is how to use a dictionary. But I mean, that's pretty it's simple to explain, but at the same time, it's not like really necessary. And I don't have an example of why we would use it right now. So I'll leave that for university. But overall, it's something that took a lot less time than it did yesterday. That's pretty much it for the very, very basics of code. So you should be able to print stuff to console, take an input from a user. You should be able to use different variable types. You should be able to use lists. You should be able to use math operators, conditional operators, logical operators, comparison operators. You should be able to use if statements, else ifs, else, and loops and functions. That is pretty much it. I don't really feel like making this any longer than it has to be for the sake of, it's 2 hours of the last day before uni. So if you guys have any other questions, thanks for sticking it through for the full 2 hours. If you have any questions about like stuff that we've covered, please let me know. There is so much more in programming in general that it's literally impossible to cover it all. But I hope that you all kind of have like a basic understanding of what programming is, the very basics of programming that apply to pretty much every programming language. So yeah, if you're still here, let me know if you have any other questions, or if you want me to like go over anything else. But otherwise, we are pretty much done. Thank you all for coming. I hope you learned how this stuff works. So yeah, if you have any other questions, let me know. This is recorded, so I will put a link to it once I can figure out how to convert it and upload it. And if you have any other questions with programming in general, or even later on in the year, just feel free to shoot me a message. I'm always happy to help with programming questions. So yeah, thank you all for coming. I hope you are now a bit more familiar with how programming works. And so when you go into your class for the very first time, you're not like, what is a program? What is Python? So yes. Is there a shortcut that highlights the function from the inside of the brackets? Is there a shortcut that highlights the function from the inside of the brackets? Sorry, what are you? A shortcut highlights the function. I'm not entirely sure what specifically you are referring to. If you like refer to like a particular line. If you don't have any other questions, and I mean, you can stick around if you want to hear the answer to whatever this question is. Feel free to head off and enjoy the last few hours of freedom. Like if I'm inside the print brackets, can I select the print thing as a whole? So if you're like here, yeah. So if you just double click, if you just like spam click a whole bunch of times, like left click, it'll do that. And if you click on, it'll select the entire line, which means that you have like issues when if I copy paste this and put it here, it has the white space here, so it doesn't work. Like it puts it in the wrong spot. I'm sure there is a shortcut. I honestly don't know it because I just use my mouse. I'm sure there is a shortcut. There's a shortcut for absolutely everything. Like you could do like that, which is a bit awkward. Like you could do this, and it doesn't even work properly, which is Control Shift and then left and right arrow. But otherwise, yeah, it's just you just kind of highlight it like that. Print. Thanks. Have a good day. Nice. Yeah, I'm glad we've got at least the print statements down. So yeah, I'm sure like literally if I search it up, like Python, how to select specific line, I'm sure it'll be a thing. Never mind. That's actually looking at text. So maybe if I do shortcut to copy or to select entire line. See, I'm sure there's something here, right? Like, select text between the cursor and the end of the text angle field. Shift Control N. Nope. Anyway, if you search it up, I'm sure it's a thing. Shift N. There we go. It'll be that one. So Shift N. Yeah, it does that. So that's one way you could probably do it. Yeah. There might be Shift Up or Down. Selects a line at a time. Oh, you can do that too. Oh, that's not quite what you're looking for. Yeah, I don't know. Realistically, I just use my mouse. I'm sure there is a way there. And this isn't really looking at Python. It's just text editing shortcut. So yeah, my overall recommendation is if you ever run into any issues, firstly, consult Google. Google is literally how people program. Without Google, I swear nobody would be able to program, especially things like Stack Overflow. If you can't figure that out, feel free to, like, if you can't figure out what's going on from Google, as long as it's not like an assignment that you're actually not allowed to ask other people for, then just, ask someone on the IT Discord or ask me. And yeah, so once you go and branch out into other different languages, if you will, things do change. They can take a bit of time to get used to, but the same concept should apply. So I've been trying to teach the concepts as well as just explaining how to do it. Am I a first year? Yes. I'm doing computer science and engineering. So if you're doing either of those, I will possibly see you or see you online in a Zoom meeting for computer science. So yes, I'm a first year, but I have been programming by myself, like self-taught, for a couple of years now, which is why I thought I might as well do this. Otherwise, if you don't have any other questions, I may just end the meeting and stop the recording and figure out how the hell to upload this 2-hour recording to like YouTube or something. Yes, thank you all for coming. And once again, if you have any other questions, even later on, feel free to just send me a message. If you want to continue learning programming as a bit of like a extension, just to reinforce what we've learned today, I'd recommend just searching up like, beginner programming challenges. So like, I'm sure this is like, write a program that prints hello world to the screen. Yeah, does stuff like this. Greets him with a name. A lot of this stuff I've probably like, it will be similar to what I've already done because it's, the stuff that you do to learn. Write a program that asks you for a number n and prints the sum of the numbers 1 to n. All this stuff is really useful. So if you literally search up beginner programming problems in Python, you'll get a massive list. And they're all really good to just, like target specific areas to improve your knowledge. But yes, thank you all for coming once again, and I will end the meeting. And enjoy the last few hours before we start tomorrow. Yeah, cool. Thank you, everyone. I'll end the meeting now.